Hey everyone, today we're diving into something that could totally flip the script on how we build powerful AI. We're going to talk about a future that isn't about having the most data, but about being the best at learning. So let's just jump right in with a big, kind of scary question. For years, it's felt like AI is this unstoppable freight train, right? Just getting bigger and smarter. But what if it's about to slam headfirst into a wall it can't break through? But here's the twist. The wall isn't a lack of computing power. Nope, we can always build faster chips. The real wall, the thing we're actually running out of, is data. High quality, unique information to feed these hungry models. And that brings us to our first big idea tonight, AI's hidden data problem. It turns out the very foundation of modern AI is being challenged by, well, just not having enough stuff to learn from. You know, for the longest time, the recipe for a smarter AI was pretty simple. Just get a mountain of good data, throw a ton of computer power at it, and boom, a better model. But that first ingredient, that endless buffet of data, well, the buffet is starting to close. And look, this isn't just some wild theory. The researchers who wrote this paper put it perfectly. This shift totally changes the game. If we can't just keep finding more data, the question becomes, how do we learn more from the data we've already got? Okay, so this sets up a really cool showdown between two totally different ways an AI can learn. I want you to think of it like this. It's the speed reader versus the deep thinker. So in one corner, you've got your autoregressive models, or AR models for short. These are the speed readers. They just tear through text from left to right, word after word, predicting what's next. It's super fast, super efficient. In the other corner, you have diffusion language models, or DLMs. These are the deep thinkers. Their whole job is to look at scrambled, broken text and figure out how to put it back together, kind of like solving a really complex jigsaw puzzle. It's slower, yeah, but way more thorough. Now these AR models, they're the reigning champs. They're the brains behind a lot of the big AI models you've probably heard of or even used. Their superpower is speed. By just looking at what came before, they can generate text like nobody's business. But that one-way street, that's also their biggest weakness. And that's where the challengers come in, the diffusion language models. Their approach is, well, completely different. They'll take a perfectly good sentence, mess it all up by blanking out words, and then their entire job is to learn how to fill in those blanks. This forces them to look at the context from all directions, before and after, not just backwards. And that right there, that's their secret weapon. So, what happens when you put these two head-to-head in a competition? Well, researchers did just that. And they discovered something really cool they called the intelligence crossover. Okay, so here's how they set up the competition. They took an AR model and a DLM model and gave them the exact same amount of training time and power. You can think of it like giving two students the same number of hours to cram for a big exam. And this is the really important part, they limited the amount of unique material they could study from. They couldn't just read 1,000 different books. They had to go back and reread the same few books over and over again. This forces them to learn deeply, not just widely. And the setup? It's a perfect simulation of the data-scarce world we're heading into. And what happened was pretty wild. At the beginning, the speed reader, that AR model, shot way out in front, which makes sense. But as both models were forced to keep rereading that same limited data, something incredible happened. The deep thinker, the DLM, it didn't just catch up. It blew right past it. And that moment, right there, that's the intelligence crossover. And this chart just lays it all out, plain as day. A DLM model got to the same level of performance as an AR model, but it did it using only 1/3 of the unique data. Think about that for a second. It learned 3 times more effectively from every single piece of information. That is a huge deal. And this wasn't just a fluke. The researchers found really clear patterns. The more fresh data you have, yeah, the longer it takes for the DLM to catch up. But, and here's the kicker for the future, the bigger the AI model gets, the sooner that crossover happens. So as we keep building these massive AIs in a world with limited new data, this crossover isn't just possible, it's pretty much inevitable. So, the big question is why? What's the secret sauce here? What gives these diffusion models such a crazy advantage when data is tight? Well, it really boils down to 3 key things that all work together. Okay, first, there's the any order learning. It's not stuck on that left to right highway, so it can spot deeper connections that AR models just can't see. Second, it uses something the researchers call super dense compute. Basically, it just squeezes every last drop of meaning out of every single piece of data. And third, the way it learns by fixing messy text, that's basically built in practice. It's constantly creating new problems for itself, which forces it to really understand the underlying concepts, not just memorize a sequence. So, you're probably thinking, okay, why not just add some of that noise and messiness to the AR models to make them better? That's a great question, and the researchers thought of that too. They tried it, and, well, it helps a little bit, but it doesn't even come close to closing the gap. And you can see it right here. Giving the AR model some noise gives it a little boost for sure, but the DLM is still playing in a completely different ballpark. Its advantage isn't just a simple trick. It's a fundamentally better way to learn when you're data starved. So where does all this leave us? What does it mean for the future of AI? Well, it all comes down to this huge fundamental trade-off between data and compute. It's a really tough choice. And here it is, the ultimate choice. On one hand, autoregressive models. They are super efficient with computing power, but they eventually hit a wall with how much they can really learn from the data you give them. They trade depth for speed. Then you have diffusion models. They're absolute beasts when it comes to compute power, but their potential to learn from data is just off the charts. They trade speed for depth. And when I say they're beasts, I am not kidding. To really max out their potential, DLMs might need more than 100 times the raw computing power to train compared to an AR model. That is a massive, massive cost. And this is the final word from the researchers themselves. If high-quality data really is the new bottleneck, then paying that massive price in compute might just be the only way forward. The only way to keep pushing the boundaries of what AI can do might be to get way better at learning from the data we already have. And that leaves us with one last question to chew on. For the past decade, AI has been a race for speed, scale, and efficiency. But as data becomes the new gold, is it possible the entire future of AI will belong not to the fastest model, but to the deepest learner?